Hi everyone, and welcome to the first microcontroller workshop of the fall semester. My name is Muhammad Atif, and I will be joined by Michael to host this workshop. So essentially, I'm going to be responsible for the hardware setup, and Michael will be taking over for the software aspect of the system. In this workshop, we will be building an alarm system. So let's go ahead and get started. We will be using Tinkercad for our simulation system over here. So first thing first is the components. We will be using Arduino. So let me go ahead and put an Arduino system.
Just think.
1 second.
Nice tricky. Oh. I'm liking. Seems that we're liking. Okay, we're good.
Okay, awesome. Then we'll go ahead and look up a breadboard.
Really?
Alright, and alright, and then next thing is we'll be using 4 LEDs. So I'll explain that 1 second. So each of these LEDs will be demonstrating how far or close we are from our alarm system, and essentially we'll be using 4 resistors also. So let's go ahead and get started. First thing first is we'll go ahead and connect our ground. So our ground we will be connecting over here to the negative terminal, and then we'll connect our 5 volts, which will be power. It's going to be connected over here. Alright, next thing we'll do is we'll connect our LEDs. So as I described briefly right now, each of these LEDs will be telling us how far or close we are from the buzzer and from the sensor. So this first LED will be telling us if we are within the range of 10 centimeters. Then the next LED will be telling us if we are between 10 and 20 centimeters. This one will be telling us if we are between 20 and 30, and the last one is if we are farther from 30 centimeters. Now let's go ahead and connect our resistors. We have a resistor over here. Let's do this. We'll go up over here a bit. Connect the resistor with the cathode portion of the LED and the ground. Connect 4 of our resistors. Alright, now next part of this system would be to have a sensor. So we will be using the ultrasonic distance sensor over here. As you can see, it has 4 pins. The first one is ground, so we'll go ahead and connect it to ground. The last one would be power, so we'll connect it to 5 volts as we have described power to be. Now there are 2 more pins. If you look at it, it has the echo and the trick pin. So each of these pins will be used for a specific task. So the echo pin is used to receive data from sensor, and the trick pin will be used to pass data to the sensor in order to activate it. So we'll connect the echo pin over here as well as the trick pin. So we'll connect the echo pin to pin number 2. Then the trick pin, we can just connect it to pin number 3. And as for the LEDs, we can also connect them one by one. So the first LED, we can just connect it to pin number 4. The next LED we can connect to pin number 5. The third LED could be connected to pin 6. And the last LED to pin 7. Alright, now the last portion that is left for the hardware aspect would be the buzzer. So we'll go ahead and use a buzzer. I will use a P as a buzzer over here. So we can just keep that over here. Now for the buzzer, the negative terminal over here will go to ground. So we can just connect it to ground over here. And the positive terminal over here can go to the pins we have. So I'll go ahead and connect it to pin 8. So that is all there is for the hardware aspect. As I described, we will be using our Arduino system, and then the breadboard we have connected 4 LEDs. Each of these LEDs will demonstrate how close or how far we are from the sensor. And now, as I described, there are 4 main pins in the sensor: the power pin, the ground pin, the echo and the trick pin, and then we have our buzzer over here, which will make an alarm sound once motion is detected close to the sensor. I'm gonna go ahead and hand this over to Michael, and then he will be showing you guys how to code this system.
Okay. Well, thank you. Hello everyone. We will so click on the code button, click on blocks and go to texts. We won't be using block code, we'll be using text. Now when coding an Arduino, we are presented with a setup function and a loop function. The setup function we called once the Arduino receives power, and we usually use it to like set up connections, while the loop function will be called every single many times a second. Right, it'll be called many times a second, and this is where we want to write our logic for the code. So to begin, I'll create constant variables, constant integer variables for the pins we are connecting. So the echo pin is connected to pin 2. We'll create a constant integer echo pin equals to 2. The trigger pin connects to pin 3. Constant int trick pin equals to 3. The first LED connects to pin 4. Const int LED 1 equals 4. The second LED connects to 5, third connects to 6, the fourth connects to 7. Const int LED 2 equals to 5. Const int LED 3 equals to 6, and constant int LED 4 equals to 7. Okay. We'll also need to connect the buzzer. We also need to write code to set up the buzzer. Now the buzzer will be connected to pin 8. Constant integer buzzer equals to 8. Okay. We've declared variables that map to the pin numbers on the Arduino. So whenever we want to pass some electricity from the Arduino to a specific pin, we'll use the pin number, the constant pin number, to reference that pin and to effectively control Arduino. Now in the setup function, we will want to declare what these pins do. The way the circuit works is that we are only going to send electricity to the buzzer, the 4 LEDs, and the trig pin of the sensor. And to tell the Arduino that we're only going to send electricity to them and not receive from them, we'll use the pin mode function. Pin mode, and we will tell the Arduino that the trig pin is going to be an output pin. That means we will write to the trigger pin or send electricity to the trigger pin. Now we'll let the Arduino know that what the 4 LEDs and the buzzer, they're going to have a pin mode of output, because we're just going to send electricity to them. So LED 1 output, pin mode, LED 2 pin mode, LED 3 buzzer output. Now we will only receive data from the echo pin on the sensor, and because we're going to receive data and not send data, we're going to use a pin mode of echo pin input, a pin mode of input. Again, this is to tell the Arduino that we are going to receive input from the echo pin, which is this echo. Now in our loop function, first things first, what we want to do in the loop function is to activate the sensor. We'll do this by telling the Arduino, we activate sensor. We do this by telling the Arduino we'll do this by resetting the trigger pin. And we do this, the reason we do this is because we need to, activate the sensor and let it know that, hey, we are ready to receive, we're ready for you to send in your data to us. We're ready for you to sense how far something is from you. Okay, so we do this by using digital write trig pin low. What this does is it deactivates the trigger pin, and after we do this, we're going to delay our code by 2 microseconds, or rather let's use 5 microseconds. We delay by 5 microseconds, or you know what, maybe we just use 2. There's a good reason why we are delaying by a couple of microseconds, and I will explain later. Next, we need to turn the trigger pin on by using digital write trig pin high. This is how we basically tell the Arduino to send some electricity to, say, a specific pin. If I were to write digital write any number of pins, like the buzzer pin high, and if I set it to high, we basically pass electricity to that pin. Okay, we're going to delay by a couple of microseconds, this time 10, and then we will set it back to low. Digital right, trick pin low. Okay, now we're done setting up the sensor. Now, by now we should have received, the sensor should have detected objects, and to get that data, well, we have to access the echo pin, and we do this by using the function pulsing echo pin high to read a pulse, and we will want to store this data in a variable integer speed equals to this. Now, the reason I'm naming the speed is because, well, the way the ultrasonic sensor works is that it sends out a ultrasonic, well, sound wave, and if you send out an ultrasonic sound wave, and when this sound hits something, it reflects off an object, and the ultrasonic sensor will detect the sound wave it sent off, and we will need to find how long the sound traveled. We'll need to put it in a variable. I should probably make this duration, how long the sound traveled in the air. The closer an object is, the faster we'll receive our signal back, and the farther away an object is from the sensor, the longer it will take for the sound to come back. And in order to make pulsing work, we'll need to delay our code by a couple of microseconds, which is why I delayed the code by 10 microseconds and 2 microseconds, all to set up the ultrasonic sensor. Now that we have how long the sound has traveled in air, we'll need to convert that sound data, time data, to distance. Convert from time to distance. Now, to do this, we need to multiply the time it took to receive that sound with the speed of sound in air. So integer distance equals to duration times the speed of sound, which is 0.0343 in centimeters per second, divided by 2. Now we have the time, we have how long it took for the sound to come back, and we know the speed of sound, well, with physics. So in order to find how far an object is, we have to multiply speed times time to give us distance. Also, we divide by 2 because the sound has to bounce back to come back to us, which means it will travel twice the distance before we'll be able to receive the sound again. So to get an accurate representation of the distance, we need to divide by 2. Now that we have our distance data, we need to do an if check to see how far an object is from the sensor. So if the distance is less than or equal to 10 centimeters, okay, if the distance is less than or equal to 10 centimeters, we will want to digital write to this LED. We want to activate this LED, but we'll leave these 3 deactivated. So digital write LED 1, high. We'll deactivate the other two LEDs by using digital write. But we write low to those LEDs. Digital write low. LED 1 high, LED 2 low. To deactivate it, LED 3 low, and LED 4 low. And also we want to pass some electricity to our buzzer. We want to pass some electricity to our buzzer if the distance is less than or equal to 10 centimeters. And we do that with the function tone. We'll do that with the function tone. We need to get the buzzer, the pin for the buzzer, which is buzzer, and the frequency to which we need to pass, the frequency we pass to your buzzer. I will choose 262 as our frequency. Now, else, if the distance is less than, or if the distance is greater than 10 centimeters, and if the distance is less than or equal to 20 centimeters, we will light up just the second LED, but we won't light up the third, the fourth, and the first one. So that will be digital write LED 2 with high, LED 1 low. So digital write LED 2 high, so pass electricity to this LED. LED 1 low, won't pass electricity to it. 3 low and 4 low. We'll also pass the tone to the buzzer, and I'll use the lower frequency, which will be 150. Right. Else, if the distance is greater than 20 and the distance is less than 25, we will copy and paste this code. Also, by the way, if you're in computer science, you're going to have to copy and paste code a lot more than you think you will. So digital write 1. So we're gonna pass electricity to the third pin, but not the first, second, or fourth pin. I will change the tone to say 120. Else, if the distance is greater than 25 and the distance is less than or equal to 30, we're gonna digital write LED 4 with high. We're gonna pass electricity to LED 4, but we want to LED 3 or 1 or 2, and we'll also pass a tone of 100 to the buzzer. And else, if the distance is more than 30, we will turn all of these LEDs off. I will also use a different function, the function no tone buzzer. I'm passing the buzzer. low. And I believe that's it. Now we'll start the simulation. Oh, there's something wrong with our code. Says LD. Ah, I see. LD3. Start simulation. Okay. So the code compiled, which is good. Now to test your ultrasonic sensor, right click on it, get this ball and we place it 19 centimeters, and this is our alarm system. As you can see, this LED is light up because when I'll stop this. This LED lit up when the ball was 19 centimeters from the sensor. If we go closer, this LED lit up. If we go further, say 17.7, this one lit up. But if we go 23, this LED lights up. Well, that's it. We have made an alarm system with Tinkercad and the Arduino. Now, do you have any questions for me? Do you have any questions in the chat, maybe? Oh, okay, no question. All right. Well, thank you for attending the workshop. I hope you all have a nice day. Oh, and also, if you want me to share, I will share the projects. I'll share the project to How do I get a constant speed for sound? Okay. Well, the speed of sound is it's a constant. Like the speed of sound in air is approximately 340 meters per second, which is 0.034 centimeters per second. Can you show us how to activate the simulation again? Okay, to activate the simulation, you need to click on Start Simulation. And click on the sensor. And you control the ball. And the buzzer rings louder the closer it is to the buzzer. But to activate the simulation, click on Start Simulation. How to activate the Hall? I don't know what you mean. Can you use a for loop for if statements? Well, you don't need a for loop. This loop function is called many times a second, right? So this is practically your main loop function, and your if function will be within this loop function. How to activate with the ball? Oh, okay. Start the simulation. First, you have to click on the ultrasonic sensor. Then you'll get the ball, and you get this field of view. You will need to control the ball. You will need to control the ball, and it will show you how far the ball is from the sensor. The closer you are to, you bring it to the sensor, the louder the sound. Okay, I'm happy to have answered all your questions. Yes, you should play with Arduino more often. Okay, any more questions? Okay. Let's see. I will share the. Oh, you're welcome for the presentation. My friend will Mohammed will share the link to the microcontroller. Well, thank you. Thank you for attending. We will get to work sharing the link to the microcontroller in case you want to look at it afterwards. You're welcome. You're welcome. Temperature sensor. Well, I'll ask my team if they want to do a temperature sensor. No, I omitted. I'll ask my team if they want to do a temperature sensor, and if they do, then we will get a temperature sensor projects soon. We'll get it to you guys soon. Okay, we shared a link to the Tinkercad project. Where can we access the link for the sensor? I just shared it to the chat. You should be able to see it. Can you see it? Can you see the project? Okay. If it doesn't get sent to the wait a second. Okay, I'll get in touch with the people at IEEE to share the projects. We'll have the project shared very soon. I'll get in touch with the people at IEEE to share it. You're welcome. Also, maybe I'll try to leave the link in the comment section when the stream is over.